Hello, this is Engineer Dan and welcome back to another geography video. This is part 2 of the part 2 series of going through revision. Now, in the first part of the series we talked about the river features of the different courses of the river. In this video we're going to be talking about flooding. So we're going to start with the hydrocycle or the water cycle. And it does look very complicated, but I'm just going to talk you through the basics. So evaporation occurs, creating a cumulus cloud. Cumulus cloud condenses, creating a nimbus cloud. Precipitation ensues, basically meaning rain. So it rains, and then if it lands on permeable land, that means water can infiltrate. Infiltration occurs, and that creates ground water flow. Now that's good. That means it takes a while for the water to get back to the river. Through flow is alright, it's just like the top layer of the soil, no, the bottom layer of the soil, and it's still slow, but it's not slow enough. You can still have a flood through flow. However, what you don't want is surface runoff. Surface runoff is when water goes on impermeable land or saturated land, and it runs on the top, creating speed. So it's a lot faster and it gets to the river faster. Ground flow is what you want. Surface runoff is definitely not what you want. So it rains. If it's permeable, infiltration occurs. And also, if there's trees or if there's a forest nearby, the trees intercept the water with their roots, and transpiration occurs, basically bringing them back in the atmosphere. Now, trees are vital to the water system for many different ways, but one of the ways that I'm going to talk that I appreciate at the minute is that trees absorb the water, meaning floods. Less water goes back into the river, basically, meaning floods are very rare in forested areas. So that is the water cycle. Cloud goes up, moves across, rains. Some goes underground. If it's groundwater flow, it goes back slowly. If it's through flow, it goes back medium. And if it's surface runoff, it goes back fast. Transpiration, basically trees get water and evaporate it through the leaves. Now, what is a flood? A flood is when the river banks overflow, causing water to invade the floodplain. I'm looking up here. So basically, when the water goes past the bankments and it invades the floodplain, it goes onto the floodplain. Now, this is obviously not very good, but this is how floodplains get created. Little sediments of alluvium and big boulders of soil start overlying, I don't know the proper word, start like setting on top of the floodplain, and then this creates a very fertile land. However, it is going to flood if you want to farm on there. That's why so many farmers farm on the floodplain, because it is very fertile and you get a good yield with the crop. So now I'm going to talk about a little bit of what we've done in class, what I think will come up on the exam. And this is linking human and natural events to flooding. So deforestation is a human event. We chop down trees, we burn down trees. And this is what I said, how it will cause flooding. So there's less water, or there's less trees to intercept the water. Sorry, ignore that. I don't know what I'm reading here. There's less water to intercept. That's meant to say trees. I made a mistake. So there's less trees to intercept precipitation, causing saturated ground, resulting in surface runoff. Now, what I've basically said there is there's less trees to absorb the water. So what will happen is the soil will get full. There's nowhere for the water to go, so it'll have to go on the surface and surface runoff, so it'll go fast. Now, my second point was natural. Well, you can argue if it's natural or not, but I'm just going to say it's natural here, and I think the exam will say it's natural. But heavy rainfall. I said large volumes of water will result in saturated grounds and runoff, surface runoff. Basically said exactly the same thing, but this is if it doesn't occur in a forest. It will rain down and soil will become full, so the water will have to go on top of the soil and surface runoff will ensue. So now, ways to stop it. This is, ways to stop it. Looking down here. Wait, is it? Yeah. Oh, I don't even need to do that at the minute then. So we have two ways. That is hard engineering and soft engineering. Hard engineering includes structures such as dams, flood reliefs, and embankments. So what a dam is, everybody knows what a dam is. The advantage of a dam is that it is very good in its job. It creates a reservoir for habitats. However, building the dam might destroy some habitats. The disadvantage of a dam is that it is very expensive. Oh yeah, and another advantage is that it creates electricity. But all of this comes with a cost. Now, flood relief is like little channels, like the highway. I think of it like little junctions and turn off. So if one channel becomes too full, it opens a gate and lets water go through another channel, basically. Embankments is building up high, like maybe a meter above the channel. So if it does flood, hopefully that meter will be enough, so the water doesn't invade the floodplain. Now, examples of soft engineering is work. Soft engineering is working with the environment. So that includes floodplain zoning, meaning you can't build on floodplains. The disadvantage of this is many people already have built on floodplains, and it's pointless destroying everything to maybe stop a flood every decade or something. Afforestation, planting trees to intercept the water so the ground doesn't become saturated, resulting in surface runoff. And then finally, restoration of rivers. Now this can include dredging rivers and fixing them, basically. So I hope you enjoyed this geography revision thingy, and I'll see you in the next video. Adios.